Alright, today's video is about division. We have already been talking about multiplication, and if you have not watched the videos on multiplication, I'd highly recommend doing so. So far, we've defined multiplication as the sum of A segments, which is some quantity, each of a length of B, and that sum is C. Now in division, just as subtraction is the opposite of addition, which we talk about in the subtraction videos, division is the opposite of multiplication. It's the number of segments, each of length B, that are created from the total length C. So if you have A and you multiply it by B, whatever those numbers may be, you're going to get some product that's called C. Well, if you take C and you divide it back down by B, you're going to wind up back with A. And we can look at some examples of that. If you have 5 times 2, that's 10. If you have 5 pieces of wood that are each 2 inches long, then you have a total of 10 inches. Well, the opposite of that, division, says if you have something that's 10 inches long and you divide it by 2, then you are going to wind up with 5. If you divide it, you say, hey, I have this piece of wood that's 10 inches long, and I want to know how many segments I can get if each segment is 2 inches long. Well, the answer is 5. And this is that sort of inverse relationship between multiplication and division. This is where it gets really important to understand that there's a little bit of flexibility because of the commutative property of multiplication when it comes to how to interpret multiplication and specifically division. When we say 3 times 5, what we're really saying is 15 is the third multiple of 5. If we're counting that by lengths of 5, 5, 10, 15, then 15 is the third number we get to when we're counting that by 5. So we can also look at this example and say, okay, well, C divided by B equals A. We're saying C is what multiple of B? 15 is this length, and we're counting by segments of 5. So how many segments of 5 are we going to get out of 15? And the answer is 3. So just like we can say that 15 is the third multiple of 5, we can say that 15 is the third multiple of 5. The same thing, it's just 2 different ways of writing it. Visualizing this on a number line is really critical. We can say, okay, well, let's see, 3 times 2. What's that going to be? What's the third multiple of 2? Well, 1, 2, 3, it's 6. Retrospectively, we can say, I have some number 6, and I want to know what multiple of 2 that is. Well, 6 divided by 2 means 6 is the blank multiple of 2. Well, what is it? Well, it's the 1, 2. It's the third multiple of 2. So here's a couple of problems. If we're at 15 and we want to know how many segments of 3 we can get from that, then we can simply count up and we can say, okay, well, let's start off. Okay, I'm going to start at 0. So there's my first segment of 3. I can get 2. I'm still under 15, right? I can get 3. I can get 4. I can get 5 segments, each of length 3 from the number 15. Same thing here. We say, okay, well, 6, 12, 18. 8 divided by 6, 18 is divided by 6 is going to be 3. Now, to kind of put it back in perspective in multiplication, 4 times 3 means I have 4 segments, each of length 3. So 3, 6, 9, 12. Sorry. The answer is going to be 12. Well, now, the opposite of that, if I have 12, right, this whole length here, and I want to break it into segments of 3, well, there's the first one. The next one, that's another segment of 3. The next one, there's a segment of 3. And then there's a segment of 3. Hey, I can get 4 segments, each of length 3, from 12. And now, this is where it gets important about how we conceptualize things. When we say 4 times 3, we mean 4 segments, 1, 2, 3, 4, that each have a length of 3. However, because of the commutative property of multiplication, which says the order in which we multiply doesn't matter, then we could also, 4 times 3 is the same thing as 3 times 4. But conceptually, how we would draw this is actually different. This is where this really starts to get important. 4 times 3, we're saying, hey, I've got 4 segments that each have a length of 3. When we say 3 times 4, we're saying, hey, I've got 3 segments and each are a length of 4. They are equal. They wind up to the same place on the number line, but the path looks different. It's two different ways of thinking of it. And this suddenly becomes very important in division. The quotient could be the length of a segment when A is divided into B equal segments. So once again, if we say 12 divided by 4, what we're saying is, if I divide 12 into 4 equal segments, what is the length of each of those segments? And we say, okay, well, that's 3, that's 3. Yeah, they're all 3. So the length is 3. 12 divided by 4 is 3. But we could just as easily say 12 divided by 4 is, if I want to divide 12 into segments that each have a length of 4, how many segments will there be? Well, there's 1, 2, 3 segments. The answer is the same. The concept is different. And I really think this is where people get tripped up with division, is because there's not one right way to think of it. Both ways are correct, and it really depends on the context. Without context, you can think of it either way, and you're going to get to the right answer. So here's an example. I'm building a porch in my backyard, and I have one big post of wood that's 18 feet, and I'm going to divide it into 6-foot-long segments. Let's say I need 3 6-foot-long pieces of wood. And I'm thinking, gee, how many strips of wood can I get from this huge 18-foot-long post? And I say, okay, well, if I'm dividing it into 6-foot segments, well, then I know that 6 feet, that's one post. Another 6 feet, now I'm going to have used 12 feet total, 2 6-foot feet post. And then I can get another one in. What's 6 plus 6 plus 6? Well, 6 plus 6 is 12, plus another 6 is 18. Hey, that's what I'm looking for, right? This 18 piece of wood, if I divide it into posts that are 6 feet long, I'm going to get 3 of them. Now let's think of another example. I'm going to bake a loaf of bread, and it's going to be 18 inches long, right? 18 inches wide. If I have 6 people coming over for dinner, and I want each of them to have a slice of bread, then how thick should the slice be? In the previous example, I had my length, and I was trying to figure out the quantity. In this example, I have the quantity, 6 people, and I'm trying to figure out how wide to cut the bread. Well, the answer's still going to be the same, but my approach is different. I say, okay, if I divide 18 into 6 segments, how wide will each segment be? And if we look down here, we can see that, well, that's 3 inches, that's 3 inches, and I have 6 slices, so each slice needs to be 3 inches wide. And this is just sort of what I just described. One last issue, 16 divided by 5. We say, okay, well, let's work on the context of how many segments can I get that are a length of 5. Well, there's 5. And then 6 to 10, there's another 5. And then there's another 5. Well, I get 3. I can't go any further, right? If I went, I mean, the next segment of 5 would take me up to 20. I don't have that much to work with. However, you may notice that I only ended at 15. So my quotient, the number of actual segments I can get, is 3. But there is a remainder of 1. There's this extra piece remaining. So in the context of maybe the bread example, well, I could get 3 slices of bread that are each 5 inches, but there's going to be this extra inch of bread that kind of goes to waste. It's a remainder. We can also think of this more materially and say, like, if I have to, like, if I sell eggs and I decide to be a renegade and I'm going to sell 5 eggs in a carton, well, you can see, okay, well, I filled 1 box. Oh, my layering is off. So there's 3, 4, 5. Hey, I can fill 2 boxes. Can I fill 3? I don't know. Let's find out. 1, 2, 3, 4, 5. Hey, I filled a 3rd box. I can't fill another one, so I just have this like random egg over here that's the remainder. So if my boss said, how many cartons of 5 can you make with 16 eggs? My answer would be 3, but there's going to be this one remainder that I can't use. So here's a couple more problems. That's all that's really left. That's the main content. I give you a couple of examples. You can pause the screen and work through them. So anyways, this is the important idea of division in its relationship to multiplication. Thank you so much.